Ja, vielen Dank. Mein Talk ist heute über Platform Engineering und ich hoffe, es ist okay für alle, wenn ich es auf Englisch halte. Deswegen, let's switch to English. My talk is about platform engineering and how platform engineering empowers our developers. I'm actually from Lufthansa Systems, so a subdivision from Lufthansa. But I think that doesn't matter too much right now. Maybe some words about myself. I'm a software architect for Netline SCAD. It's one product of a product family which is quite large. I will show you also in a minute. And I'm currently responsible for the modernization of our product. I started 2015 with my dual studies and also had a part-time master's in IT security. So what is Netline? I told you that I'm working on one of those products, which is Netline SCAD. It's part of a big family of products. So we have everything that supports airlines pretty much. So from scheduling, which is like 3 years, all the way to 7 days prior to the flight. We have a lot of optimizers in this area, but we also have operations products in our product suite. So it's practically all the processes a airline company can have. We currently have more than 70 airline customers and more than 15 delivery teams. And as you can see, it's like quite a large organization. So we thought about how can we actually improve our product by introducing platform engineering. What are our main challenges? So first of all, right now, as you saw it, we have quite a lot of silos. So every product right now somehow acts on itself. And we want to change that in the future because also that means that they deliver their products in different ways. We have a lot of different practices. So our architecture is quite heterogeneous. They operate differently, and also reinventing kind of processes is actually quite hard because you have to reinvent over and over and over and over again. And right now, actually, as I said, I'm on the modernization of our product. We actually are doing a kind of a paradigm shift. So right now, we had a lot of power clients, which are actually installed somewhere in the cloud, but still, this is not really the modern architecture stack. So we want to now transition to web services, and obviously, this comes with a lot of changes in the organization, a lot of changes in technology. And practically, this means that there's a lot of cognitive load on the developers. So if everyone has to do this themselves, every team has to do this themselves, every developer has to educate themselves, then you are up for a very, very long transition phase. And if we look at this CNCF landscape, maybe this is familiar to one or two of you, this is the Cloud Native Computing Foundation's landscape. So these are all the cloud native products that you practically need for operating your product in the cloud, but also a lot of supporting tools. And yeah, so as you can see, if you want to learn all of this, it's practically impossible. Even like the architects, they don't really know everything about it, but we need some kind of solution for this. And there are practically two ways to do this. One is streamlining of our development processes. So to get the efficiency and the consistency across the whole product family. And the second thing is, and this is what my talk is about today, is about actually building a platform engineering team, which then is a centralized, skilled team actually dealing with all of those technologies that you just saw. And this is also an interface actually to site reliability engineering, which was the prior talk that we saw. So as you can see, there are also a lot of building up technologies, building up processes. So first of all, let's look at platform engineering. So what is it? Practically, we're trying to solve complexity of our infrastructure using one of our teams. So you can see here, it's actually one of the key tools of Gartner. For those who are familiar, Gartner practically looks at the future, looks at new IT skills that you need, IT processes, and one of the main ones is actually platform engineering. So we build an infrastructure platform, and this platform provides a lot of features. One is reusable components, so every product can just pick and choose via a self-service platform. but they are also internal consultants. So if any of the product teams actually has a problem they want to solve, they have a challenge, then they can go to this platform engineering team to actually tackle it. And on the top of everything, you see all the product services. So it's practically the whole stack, and eventually, all the way on the top, you have your product. So looking at the right side, what kind of facilities does it give it to you? It's first of all, it's the important part is automation. So you can think about these IT landscapes. I mean, there are a lot of tasks you have to do. So every time you can automate things, you're practically gaining speed over like a large set of services. We want to do standardization, self-service, which I just tackled, but also we want to learn from our products, both in development, but also in production. And for that, we need monitoring. And since this is practically used by all of our products, we have a good way to scale our solutions. And of course, that's the most important part. We are practically critical infrastructure, so we have to have security also on our minds. Otherwise, if for some security reason we have to ground the aircraft, you can, I think, understand that this will be very costly and cost a lot of reputation. So how does this look like for our platform engineering team and also for our application developers? Practically, the platform engineering team gives a lot of services. And those services, you can see on the right side, are, first of all, a lot of tools, tool capabilities, but also automation that comes with the use of tools. We introduced a paradigm shift using DevOps, so it's not like the Zero idea that you practically develop your code and then you just give it over to operations and they just operate the product for you. But to be able to learn from your product, to be able to learn from the users, you have to have dev and ops capabilities to be able to actually get the feedback back and use the feedback in your planning. So as I said, infrastructure and operations, and across all of those tools, we introduce security. But as I said, we also want to empower our developers. So how do we do that? So platform engineering as such doesn't really give you the empowering part, but this is the thing that we are really proud of regarding platform engineering. So as I said, first of all, we introduced a culture shift, which is DevOps. So you're not just coding something, you're trying this out, you test it, and then you give it to operations. But what you do is you have the whole development lifecycle as part of your team's responsibility. So from the planning, from coding, building, testing, and then all the way to ops as well. So we release our code, we automate this whole process, we deploy it, and then by operations, we're actually getting the feedback that we can then use in planning again. And at many of those stages, we actually introduced some nice features, I would say. So this is the empowering part. One of it is we have pull request environments by now, so you can practically get rid of works on my machine. So every time you push your code, in our case to GitHub, you will get an automated deployed environment that you can give to your PO, that you can show that, well, my code is working. Please have a look and validate it. Secondly, we introduced GitOps practices. So this is how to scale operations. And last, I cannot give enough emphasis on this topic. It's about monitoring and getting the feedback. So let's have a look at our pull request environments. So let's pretend I developed my code. I'm really proud of it. I tested it locally. And then suddenly, well, I want to try it out on our dev environment and it just breaks. This is, let's say, how usually in the past things worked. Sometimes you're lucky and it works on dev, sometimes you're not. And to get you ease of mind, we created pull request environments. So you create your pull request, you have your shiny feature, then you just wait a couple of moments until your code is built, is linted, all the security checks are done. So you grab a coffee and then you come back. about 4 minutes later, and you get a URL to our internal development environments. And you can click on it, and you practically see the code working in an environment. So here you can see this is actually what we are working on right now. This is the modernization of our Netline SCAD product. And on the top, you see you have a new pull request environment, and you can show your PO, well, I had this shiny new feature, I don't know, created some new color scheme, so it looks much more fancy, and yeah, the user is fine with that. Then you actually, of course, later merge it, and then suddenly it hits prod. But the question is, how does it hit prod, and how can you have ease of mind? And this is practically what we do here. So this is the whole automation infrastructure. So this is practically how the pull requests work. So we have a tool, ArgoCD. You also saw it previously in the environment. It looks at all the pull requests, it monitors them, it really pulls the GitHub API to see if there are new pull requests available. And then it spawns a complete new environment for you in our Kubernetes cluster. In our namespace could also be the same namespace, because you want to see it also in action with all of your other code and all of your other deployments. And then, you can have a look, you can create a preview, you put this into code review, and suddenly it will also be in prod. And this is practically how this looks like. So what we do is we have two repositories. One is for our infrastructure, and one is for our resources. So what our developers do is they just push the code infrastructure, so everything is infrastructure as code, into GitHub. And this is then actually scaled out to all of our Kubernetes clusters. So of course we have some gates, but what it is technically is we are just running Terraform on our pull request environments, which create Kubernetes, which spawn ArgoCD. And ArgoCD is, as you saw it before, the tool that also creates our pull requests, and it spawns so-called Helm charts. And Helm chart is one of those key technologies that helped us to achieve this platform, because it can boilerplate your whole environment. So it's practically a blueprint, and you enrich this blueprint with configuration. So for example, with the database URL, or with whatever tags, so you can differentiate the different environments. But then you can push the same code, the same boilerplate, not only to dev, but also to your productive environment. So this is practically where it scales. And if you do this, and you configured everything hopefully the correct way, then it should look like the same environment should look like in dev. So you have a so-called dev-prod parity, which is one of the key aspects here. So whenever you do something in development, practically you can be sure that it also works in production. So this is GitOps on a very high level. And then, as I said, that's a big emphasis on our end. We also look at observability. What is observability? Practically, it is creating metrics, creating traces in your environment to know exactly how infrastructure works, how your Docker environment works, how your application works, but also, let's say, your database, for example. And then you put all of those information into one pot. This is this centralized monitoring on the left side, and you let it analyze by a lot of tools. So practically those are also the tools that we use both in our development environment and So practically analyzing this, looking at the Grafana, we can then get feedback and also understand better how our application behaves in the productive environment or in the test environment, and then plan accordingly in the next iteration. So another question is, like, if you want to actually set this kind of platform engineering up in your environment, then you ask yourself, what do you have to do? And this is our yeah, let's say this is our starting position. So we had a lot of application development teams. It's about 15, as I said in one of the first slides. And then we thought, well, we have a lot of dependencies to the site reliability engineering team, to cloud operations, to application operations. And we need to have a kind of interface in between it that every developer, every development team can use. And this is the so-called platform engineering that we built up. And what we did next is we also put Git or DevOps engineers into every team that can then actually interface with the platform engineering team. And that's a very important part of this transition, because now that you have the DevOps engineers, they know exactly how your application should work both in dev and prod. And they can enrich and, let's say, talk to the platform engineering team and learn. And then they can raise the bar over and over and over again, because, for example, one application team has a certain aspect in one area, they can raise the bar there. Then the next time the other team actually needs the same features, then, well, it's already there. You're using the same platform, so you speed up the whole development. And this is practically how we set up our infrastructure today, and this is practically our target goal right now. But of course, there are a lot of things that we still have to tackle, and we did not finish our platform engineering journey here. So one thing that we want to look at definitely is the DevSecOps. So also putting security upfront in our development lifecycle. Second is actually using AI and machine learning to look at our monitoring, look at our traces and so on, and analyze this data to actually make decisions for us. To, for example, say, well, you have a problem in one area, for example, one of our API calls takes so long, then it can automatically raise this to us, and we can have a look and maybe get a new version out. And then obviously there's a big trend, so this is green IT. So we are building up a lot of workloads, a lot of computation is needed for our services, and even more than before. So we have to have a look at how we can actually use those resources the most efficient way. All right, so that's already it. That's my presentation. Thanks so much for listening. This is my LinkedIn, so if you have any follow-up questions, you can also contact me there. Other than that, I would like to ask if there are any questions. All the way to the back. Is there maybe a microphone?
Awesome. Thanks a lot for the presentation. I have actually two questions.
Sure.
One would be, is there a reason why you have just chosen dev and prod as environments without having staging or queue or testing? And
Yeah.
The second question would be, have you already included something like port or backstage as an internal developer?
Could you repeat that?
Backstage or port, have you something like that in mind as an internal developer portal or something like this?
Yeah, okay, so for the first question regarding user acceptance tests and so on, we're actually having more than 70 customers, so we have a lot of environments. We have an internal demo environment, which is practically a UAT, so a test environment as well. But then for every customer, there's again a test environment and a productive environment. So there are a lot of environments, of course, and that's also the reason why we went this way, because like for every customer, you have 4 environments already, and then it just scales up tremendously. So that's like one aspect that I wanted to show, but of course, it's better to understand if there's just dev and prod, but we certainly do have multiple environments in between. Second question regarding backstage. We actually have a backstage environment in our infrastructure, so we tried that out. But for us, it was too much of a hassle for now. So you just need some support there. You need resources for this, which we didn't see yet that we needed. So first off, we want to do this right. And then, certainly it is on our agenda, but but we don't have any, let's say, productive environment yet. But thanks for the question. It's something we looked at. Yeah. Any other question?